By the end of this lesson, you'll be able to describe the ISO OSI model and hopefully identify interconnecting devices in the OSI model. So first of all, why ISO OSI? What does it all mean? Well, it was established in 1947. The International Standards Organization, ISO, is dedicated to worldwide standards. One of these standards is the Open Systems Interconnection Model, which covers all aspects of networking. It is open so that any vendor equipment can communicate with any similar equipment made by a different vendor. It is not a protocol, but a model of operation. First of all, we have the physical layer. This concerns the media type and defines the electrical interface connectors distance such as Cat5, Cat6, and is usually defined by standards such as 10BASE-T, etc. Fiber optic, for instance, could be single mode, multi-mode, wavelength division multiplexing, radio link such as ground-based microwave, SHF, UHF. The data link layer is responsible for delivering data units or groups of bits from one node to the next without errors. It accepts data from layer 3 and adds headers and trailers to contain addresses and other control information, usually called a frame. It deals with machine access codes called MAC addresses. The network layer is responsible for the source to destination delivery of a packet across multiple network links. To do this, it provides switching and routing and uses logical addresses such as IP addresses. It treats each packet independently, like a datagram. The transport layer concerns itself with the end-to-end delivery of all the packets and ensures they get there in the right order and flow at the correct rate. The transport layer gets the entire message to the correct application on the computer. The session layer is a dialog controller. It establishes and maintains and synchronizes the interaction between communicating devices. It also closes each session correctly. The presentation layer ensures that devices can interoperate. It translates one type of code into another, such as ASCII to EBCDIC. It may also apply compression and apply encryption. The application layer allows the user to access the network. It provides interfaces for email, remote file access, and transfer. In peer-to-peer communication, each layer calls upon the services of the layer below it. However, between machines, each layer communicates with its peer in the other machine. This is governed by a series of rules and conventions called protocols. At layer 1, the physical layer, it is direct. There are a number of bits sent to the other machine in electromagnetic format. However, communication from application to application must first go through each layer. If transmission goes through an intermediate node, such as a bridge or a router, only layers 1 to 3 are looked at. Since the data is not for them and is being passed on, it will be reconstituted so that it is clean and will be deciphered at the other end. So to summarize, application layer allows access to network resources. Presentation layer translates, encrypts and compresses data. Session layer establishes and controls the session. The transport layer provides reliable end-to-end message delivery and error recovery. The network layer moves packets from source to destination, provides internetworking. The data link layer organizes bits into frames for node-to-node delivery. And the physical layer transmits bits over a medium and provides a specification to do so.